Today we're going to talk about radicals and rational exponents again. This time we're going to add and subtract first. They must have the same index and the same radicand. For example, these two, there's 1 of the cube root of 2 and 5 of the cube root of 2, and altogether that leaves 6 cube roots of 2. You add it just as though it's a variable. And these two, these are not like radicands, but you can simplify. 50 goes down to 25 times 2, so square root of 25 can come out and join the 2. Make it 5. Square root of 2 is multiplied by 2. And then the 12 times the square root of 8, the 8 is 4 times 2. 4 can come out as 2 square root of 2. This time you join the numbers on the outside, that's 10 square root of 2 plus 24 square root of 2. That makes a total of 34 square roots of 2. Next one, these don't have the same index. This is a square root, this is a cube root, so this is not possible. Next, if we multiply radical expressions, they must have the same index again. So for distributing the square root of 11, when you multiply with the same index, you can multiply the numbers underneath. The radicands go together. 11 times 13 is 143, and 11 times 15 is 165. If you're taking a binomial and squaring it, it's like you're going to write it twice and multiply it by itself. So this time you're going to FOIL or distribute twice. 7 times 7 is 49. Outside is negative 7 times the square root of 8. Inside is negative 7 times the square root of 8 again. And last, negative times negative is positive. Square root of 8 times square root of 8 is 8. Put the like terms together. 49 plus 8 is 57. And negative 7 of the square root of 8 and negative 7 of the square root of 8 makes negative 14 of the square root of 8. But square root of 8 can be simplified to 4 times 2. 4 comes out and joins the 14. So it's 57 minus 14 times 2 is 28 square root of 2. When you're dividing rational expressions, from yesterday we realized that no radicals can occur in a denominator. So we must rationalize the denominator. To get rid of the radical in the denominator. In order to rationalize the denominator, we multiply by another radical expression or by the conjugate. For example, in this case, we have a square root of 5 in the denominator that we need to get rid of. We're going to multiply by a big 1, which is square root of 5, divided by square root of 5. Numerator multiplies across as 8 square root of 5. Denominator multiplies as 3 times square root of 5 times square root of 5 is just 5. And we've succeeded in our goal of getting rid of the radical in denominator, and 3 times 5 is 15. Second one, we have two radicals with a minus sign in the middle. We have to multiply by the conjugate. We're going to make it look like a big 1 by multiplying the numerator and the denominator by square root of 7 plus square root of 3. In the numerator, we're going to multiply and keep it separate in case we can cancel. In the denominator, you're going to FOIL. Square root of 7 times square root of 7 is 7 for first. Outside is square root of 7 times square root of 3, which is a square root of 21. Inside is a negative square root of 21. Last, positive times negative is negative. Square root of 3 times square root of 3 is 3. In the numerator, we're just going to rewrite it. In the denominator, we can simplify. Square root of 21 and square root of 21 cancel. 7 minus 3 is 4. However, you can go one more step. The 2 and the 4 can reduce. You're left with y times the quantity of square root of 7 plus square root of 3 in the numerator and 2 in the denominator.